So what we did first was we drew just a little sketch of this parabola that has a focus at 0, 2. We sketched our parabola. We sketched our focus. We'll call that F. And then it has a directrix at y equals -2. Remember, if it's an equation that is just y equals, it's going to be horizontal, which is opposite of when we did the AOS, the axis of symmetry. That was vertical, right? So y equals -2 is going to be horizontal. And that was our directrix. And what's special about the focus of the directrix is I can pick any point on my parabola, any point at all, and that point is the same distance from the focus as it is to the directrix. It's the exact same distance. Whoops. Sorry. So we're going to call that point on the parabola, we're going to call that P, and we don't know the x or the y value of that point. So we'll just call that point xy. And then the point on the directrix that lines up with this red point, the x value is going to be the same. So we'll call that x. And then the y value is -2. And let's just call that point D. So these two sections, these two lines are equidistant from the parabola. They're the same distance. And that's why we did distance formula yesterday. So we're going to use the distance formula to find the distance from F to P and to find the distance from P to D and set them equal to each other, because they are equal to each other. And once we've done this, we will have the equation of that parabola. So then we used our distance formula. And the first one we did from points P to D. So point P, we're going to do y minus from point, oops, just not P to F, sorry, F to P. We're going to go y minus 2 squared plus, then we do our x values, x minus 0 squared. So that's from F to P. And then we are going to do our distance formula again from P to D. So I'm going to take y minus -2 squared plus x minus x squared. So we just plug that into our distance formula. And then we started to simplify it, and that's kind of where we left off last class. Right here, we had done x minus 0 squared is x squared. Over on this side, we did x minus x, oops, that's supposed to say x squared. X minus x squared, that's 0. And then what did we need to do for y minus 2 squared? Yeah, we had to write it twice. And we had to FOIL, so we're going to do y squared, and then minus 2y, and then minus 2y, and plus 4. Same thing on the other side. I could change that to y plus 2, and then we're going to write it twice, and use our distributing FOIL method. Y squared plus 2y plus 2y plus 4. All right, this is where we left off, right? Let's just combine like terms. If we see any like terms underneath those square roots, let's combine like terms. Y squared, what do I get? Minus 4y plus 4 and plus x squared. On the other side, like term, y squared plus 4y plus 4. All right, none of the parabola equations, none of the quadratic equations that we had seen look like that. So we're going to make it look more like the equations we had seen in class so far. So what I want to do is I want to get rid of the square root symbol. Tell me what undoes a square root symbol. What's the opposite operation of a square root symbol, Nick?
Squared.
Squared, right. So you are allowed to take the entire side of the equation and put it squared. As long as you do it to both sides, you can do that. And we want to do that to both sides because we want to get rid of both of those square roots. So now we just have y squared minus 4y plus 4 plus x squared equals y squared plus 4y plus 4. All right. And we're trying to get this to a quadratic equation, like any of them that we had just taken that quiz on. So I'm going to take stuff away from both sides, or add stuff to both sides so that it looks more like what we've seen. And anybody have a suggestion of something that we could take away from both sides? Gino, what do you think?
Just take away the y squared from both sides.
Right. So if we subtract the y squared from both sides, we now have negative 4y plus 4 plus x squared equals 4y plus 4. Where are the notes that you already have? Okay, so now what we can do from both sides, is there anything else we can maybe subtract away from both sides? You guys see what we can get from both sides? Can we just take it away? Yeah, let's do that, minus 4 from both sides. So I subtracted the 4 from both sides, and those just canceled out. Now it's looking a lot simpler. What we're actually trying to do is we're trying to make this say y equals. We're trying to make this equation so that y is by itself. So now you need to learn the stuff that, or use the stuff you learned in Algebra 1. We need to just solve for y. What could I possibly do to both sides? Can I have y's on both sides if I'm solving for y? What should I do? Isaac, what should I do? Add 4y. Perfect. Oh, we're so close. It needs to say y equals, what should I do?
Flip it and divide by 8 on both sides. So like y is on the left.
Oh, that's what I didn't know what flip it.
Yeah.
I'll just do that second, but yeah. Okay, so we're going to divide by 8 both sides. And instead of dividing by 8, you can multiply by its reciprocal. So I'm going to write this as y equals 1/8 x squared. Rather than writing it divide by 8, I'm going to write 1/8 x squared. And now we have y equals. Yes, Emily?
Like what the yellow is?
Yeah.
Instead of adding the 4y, could you just on the other side divide it by 4?
Well, if you divide by 4, you would have to, I'm going to do this and erase it. If you divide by 4, you would have to divide everything by 4, which means you'd be dividing the x by 4 also, which, sure, you could do that, but it might make it more challenging a little bit further, I just usually like to leave the division to the last step. Okay? So we're going to do that exact same thing again, but on the next page. So flip it over. And I will help you get started. There's not a lot of space, so you probably want to use the space above the question along with below it. Sorry. Next time I'll make more space. Start by sketching a graph, and this one's a little bit more challenging to graph, so I'm going to help you through the graph part. It says the focus is at 0, -3, and the directrix is at y equals 3. So we have our directrix all the way up at y equals 3. You're thinking like x and y axis. And our focus is at 0, -3. Then which way is this parabola going to open? It's going to open down. The focus is always on the inside of the parabola. Can you tell where the vertex is going to be?
Yeah, it's halfway between both.
It's the same distance away from the focus and the directrix, so it's right there at 0, 0. Now, I don't know much else about this parabola yet, and that's why we're going to do this to find the equation. So we're going to pick any point on this parabola, any point you want. There's a point. I'm going to call it P, and I'm going to call that point X, Y. We're going to connect that point to the focus and to the directrix. And that directrix point, we'll call that D. And that point has the same X as the parabola, and then the Y value is 3. So we have our point XY, we have our focus F, 0, -3, and our directrix point X3. And then on that first example, we were trying to find the distance between which 2 points? These two. Right. So we're trying to find the distance between P and D and P and F. So I'm going to go ahead and give you a moment to plug stuff in, start figuring it out, and then we'll come back and fill it in. So we have already looked at parabolas that open up and down. And we know their equation is y equals something times x squared. This formula here, y equals 1 over 4p times x squared, that is how we find the focus and the directrix. The p value goes into the focus right here, 0p, that's the focus. So once you know what p is, then you can find the focus. The directrix is y equals -p. Once you know what p is, you change the sign, and that becomes the directrix. So all this information is in this chart. But today new, we also have horizontal opening parabolas, ones that open left or right. Everything you'll see in the formulas are just complete opposite of the vertical ones. So our equation is not y equals, it's now x equals. It has a y squared in it instead of an x squared. It's just everything, just the x and the y switched. The focus is now p0. It's still p, but you put the p first. The directrix is x equals -p. The axis of symmetry is now y equals. Goes the other way. And then if it is positive, if the p value is positive, then the focus is going to be to the right. The parabola is going to open to the right. If it's negative, it's going to open to the left. So we're going to identify the focus, directrix, and axis of symmetry of negative 4x equals y squared and graph the equation. Example 2. Let's decide right now, negative 4x equals y squared before we do anything else. Is this going to be the vertical parabola or a horizontal one that's new? This is the horizontal one because of the y squared. So I know my axis of symmetry already. My axis of symmetry, you look at the chart. You see where it is in the chart? With the axis of symmetry. It's right next to the horizontal axis of symmetry. It's in bold. What's it say? Y equals 0. So you're going to write down your axis of symmetry. Y equals 0. Then I'm going to go and I'm going to graph that. And since it's y equals, that one's going to be horizontal at 0. There's my axis of symmetry. I am color coding the things that I graph so you can follow it later if you need to. And then from that chart, I'm also going to write down the equation formula for this kind. The equation formula from that chart is x equals 1 over 4p y squared. That came just from the chart. Does my formula say, does my equation that I was given, does that say x equals right now? No, so I need to change that so it says x equals. What am I going to do to both sides of that to make it say x equals? Okay, I can divide by negative 4. I can also multiply by the reciprocal. What's the reciprocal of negative 4? Negative a fourth, and then y squared. So the reason why I want it like that, so I can use my formula easy. We're going to find our p-value. To find p. So I'm writing to find p there, so when you go back and you look at your notes, you know what you were doing. We were trying to find p. We're going to take what both the formula and our equation that we were given, I'm going to take both of them, what x equals, and set it equal to each other. I'm going to write the formula, 1 over 4p y squared, and I'm going to set that equal to my equation, negative 1 over 4 y squared. This is how we find p. Both sides have a y squared multiplied by the number. Both sides do. So I'm going to divide out that y squared from both sides. So I have 1 over 4p is equal to negative 1 over 4. Now to solve, to find p, there are many different ways you could do this. And as long as you're getting p, I don't mind that you choose a different way than I do it. Just going to show you the way that I think is the easiest. And that is to just cross multiply and solve. So we're going to multiply 4 times negative 4p times negative 1. That's negative 4p equal to 1 times 4. 4. And then I just have to solve for p by dividing by negative 4. So I solve for P and I get P is -1. So now we can answer the question about what's the focus and what's the directrix, because those are just formulas that you can look in your chart. So let's write down the focus. What does the formula say for horizontal focus? What's the formula tell me on your chart? P0. So if I put P right there, I get -1, 0. That's my focus. Directrix. What's the formula from your chart? You need to look and find it. What's the formula say? X equals -P. That's the formula. I'm going to write down X equals, then I'm going to do -1. What's negative? -1. +1. So that's my directrix. Now let's go put those on the graph. So put a dot at -1, 0 for your focus. The directrix is a dashed line at x equals 1. Hold on. All right, so -1, 0 is my focus, and my directrix is a dashed line at x equals 1. 1, sorry. Something I didn't talk about yet, because it's in the directions, but in that chart, where is our vertex for all of these that we're doing? Where's our vertex?
0,
0, 0. Let's put our vertex in there too. Can you tell which direction this is going to open?
Yes.
The parabola is kind of swallowing the focus. Which way is the parabola going to open? To the left. Okay, but before I draw that, I want to be accurate. We're in Algebra 2 now. We can be accurate. We're going to find another point by just plugging it into the equation. We're going to find another point so we can graph accurately. So I'm going to use the equation. I'm just going to recopy it down below so I don't have to keep scrolling. Our equation was -1/4 y squared. X equals -1/4 y squared. And when you plug in, and it's the horizontal kind, you don't plug in for x. You actually plug in for y. So we're going to pick any y we want. You can pick any y. But, so I'm going to think ahead. I want to pick something that when I plug it in and I multiply by 1/4, I'm not left with an ugly looking fraction. So what can I maybe plug in that I'm going to square? I could plug in 4. What else? I could plug in 2.
8.
Right. Anything that 4 is not going to make look terrible, divided by 4. So let's try plugging in 2. So let's try y equals 2. Then I'm going to have x equals -1/4 2 squared. So x equals -1/4 times 4, which is -1. So that ordered pair that I'm plotting is -1, 2. Make sure that you put it back into x, y before you actually plot it, because everything's backwards, it gets confusing. So go ahead and plot that point. And if I plot that point, what? Yes, perfect. If I plot that point, I actually have 2. What was that point? It was -1, 2. Then I also have a mirror point. All right, let's try that one more time. Let's plug in one more point. Let's plug in, what did you guys say before? Plugging in 4. Let's plug in 4. So we're going to do not y, just kidding. X equals negative 1/4 4 squared. So x equals negative 1/4 times 16, which is negative 4. So our ordered pair for this one is going to be negative 4, comma, 4. And the mirror point. Excellent, you just grabbed your first horizontal parabola.
Is there any way to put these into a graph or anything, or no?
Nope.